Hi children, how are you all? After a long time I came back to you people, and today I am going to give some tricks about hybridization, and hybridization is important for as well NEET, advanced and mains also. Okay, so I hope so everybody is good, doing well. Okay, so first, what is hybridization? We learn how to determine by seeing that compound of that example is having which type of hybridization, like SP, SP2, SP3. Is there many are there, but still I am teaching only SP, SP2, SP3. First we will go to general procedure, then we will learn trick. Okay, till end please do watch, then we will learn nice trick about hybridization. Okay na children, shall we start? Okay, what is hybridization? First, hybridization. And the formed orbitals are called hybrid orbitals. Okay children? Okay children, hybridization we have seen. Now formation of CH4, BCl2, BCl3, like SP, SP2 hybridization. Example how it will form. Okay, first we will learn SP hybridization. Okay, first SP. Okay children, SP hybridization. Example we are taking beryllium chloride, BeCl2. First of all we should know beryllium atomic number. What is beryllium atomic number? Hydrogen, helium, lithium, beryllium. So 4. So beryllium 4 means what is the configuration, electronic configuration? 1s2, 2s2 in ground state. Okay, then we will see through orbitals. In s orbital, 1s orbital 2 electrons and 2s orbital 2 electrons. Okay, then we will go for excited state. One minute children. Okay, excited state. Excited state means from ground state to upper state electron will transfer. So after 2s, what will come? 1s2, 2s and 2p0, 2s to 2p0. But what we are telling as here from ground state to excited state, one electron is transferred. Then 1s2 as well as usual. Then 2s, how many electrons are there? 2 electrons are there. But 1 electron will be here, and in p orbital there is no electrons before. But now it shifted one more electron to 2p orbital. So what is the configuration now? 1s2, 2s, 1 and 2p1. Okay, then we'll see now chlorine. Chlorine atomic number how much? 17. What is the configuration? 1s2, 2s2, 2p6, 3s2, 3p7. Sorry, 3p5. So how many last shell we have to take? Then s orbital 2 electrons, in p orbital there is 5 electrons. Okay. Then here 3, 4, 5. How many vacant unpaired electrons are there? Unpaired electron is there? 1. Okay. This 1 electron. But how many chlorines are there? Total 2 chlorines are there. So like this it will be forming. B is having how many electrons? 2 electrons, 2s1 and 2p1. Then chlorine is having here total 1 chlorine is having 1 electron, total 3 chlorines. So sorry, 2 chlorines. Then how many electrons? 2 electrons. Okay children, here 2 electrons are there, here 2 electrons. It will be paired with this and it will be forming BeCl2. So how many s orbitals are reacting? 1s. And how many p orbitals are reacting? 1p. So sp hybridization. Then what we are thinking? Bond angle. Bond angle is 180 degrees. What is the shape? B is having linear shape. 180 degrees. So linear shape. Okay children. Next. Okay children, second one is sp2 hybridization. Example, which one we are taking? PCl3. So boron, firstly we are taking boron. Atomic number is 5, 1s2, 2s2, 2p1. This is ground state electronic configuration. In ground state, how many electrons are there in s? 1 electron. In p orbital, s orbital is having 2 electrons, p orbital is having 1 electron. Then excited state we'll see now. 2s, 2p. Here s is having 2 electrons. From here to here 1 electron jumps, means in p orbital 2 electrons, s orbital is having 1 electron. Then see here how many vacants are there? 1, 2, 3. 3 vacant orbitals are there. Then if you take before like chlorine atomic number 17. 1s2, 2s2, 2p6, 3s2, 3p5. So valence shell, ground state, what is the configuration? 3s2, 3p5. Then we can see here s orbital is having 2 electrons. In p orbital there is a 5 electrons. Okay, if you see here only 1 unpaired electron is there. But total how many chlorines we are taking? 3 chlorines. So here boron is having 3 unpaired electrons. One is S, this is P, this is P. Okay. Then chlorine is having, how many chlorines we are taking? 3 chlorines. If you see here, chlorine, there are only 1 unpaired electron, but 3 chlorines, 3 we are having 3 chlorines. Then these all chlorine electrons are bond formed between boron. So it will be as BCl3. Okay. What is the shape? Okay. What is the shape? Here trigonal planar. What is the hybridization? Children, what is the hybridization? Hybridization is sp2 and bond angle is how much? Bond angle is 120 degrees. Okay, this is about sp2 hybridization. Next we'll see. Okay children, next third one is sp3 hybridization. What is the example? CH4. So CH4 carbon atomic number is 6. What is the configuration? 1s2, 2s2, 2p2. In which state? Ground state. Then excited state. So here first we will write how many electrons are there. Then excited state, s orbital and p orbital. If you take from here to here, 1 electron will jump. Then s orbital is having 1 electron. In p orbitals we are having 3 electrons. Totally 4 vacant orbitals are there. Sorry, 4 vacant unpaired electrons are there. Then hydrogen atomic number how much? 1. So 1 is 1. So in ground state, excited state, There is no excited state because only one electron. Then if you see here, only one electron. But total how many hydrogens are having? 4 hydrogens. Then 4 electrons. Then carbon is having only 1. Then carbon is having total 4 orbitals. See here, how many electrons are there? P2s, s orbital 1, p, p, p. Total it will be pair up like this. Then it will form, see here, CH4 molecule. Like shape is what is the bond angle here? 109 degrees, 28 minutes. So what is the shape? Here, tetrahedral or hedron. Then what is the hybridization here? Here what is hybridization, children? sp3. Good. Here 108 degrees, 28 minutes. This is about general procedure for learning hybridization. Now we will see trick. Okay, children? One. Okay, now children. Now we are going to see example. First example, what I have taken here? Ethane. Eth means 2 carbons. Ane means all single bonds. By seeing type of bond, how we can tell about hybridization. Okay. First trick is sp, sp2, sp3. Okay. By seeing bond, first sp bond means all are triple bond. If it is having any compound triple bond means what we will call it as sp hybridization. Next, if it is double bonded compound, that is called sp2 hybridization. Then we'll write it down here. sp means triple bond, sp2 means double bond, sp3 means single bond. Okay. Okay, children. Look at here. sp means triple bond, sp2 means double bond, then sp3 means single bond. Okay. Look at here. This carbon is having all are single bonds. So this is sp carbon. Next, this carbon is having all are single bonds. Single bonds means what we are telling? sp3 hybridization. So this carbon is also sp3. Next example, we are seeing ethylene. Understood, children? Next, by seeing this compound, if you write structure like this carbon, we have to see for which one we are finding out hybridization. For that we have to see around that carbon around we have to see. Like suppose this carbon is having only single bonds, I can write here sp3 hybridization. No, children. So we have to see both the sides, left, down, up. Okay, up and down. See here, left and right also you have to see. First carbon is having double bond. So single bond as well double bond it is having means we have to consider only higher bond, double bond. So here this carbon is having which bond? Double bond means sp2 hybridization. Next, this carbon, same. Single bonds, double bonds. So we have to consider this carbon also sp2 hybridization. Children, next example you see ethane, triple bond. So if you write structure CH, triple bond CH. See here, this carbon is having triple bond and single bond. We have to consider higher bond, triple bond. So triple bond means what we will call it as sp hybridization. Even this carbon is having triple bond and single bond. This bond is higher, so this is sp hybridization. Next, children, fourth example. We are not writing names from here. because number of bonds it is there. While we are writing, time it will take it. Just we will learn trick. Okay, this carbon is having normal structure I wrote. So hydrogens means we know single bonds, and between carbon and carbon there is a double bond. So we have to consider double bond. So this carbon is having sp2 hybridization. Same thing here also, double bond, and hydrogen single bond. So that double bond means what we will consider sp2. This carbon is also having sp2 hybridization. Next, look at here children. This carbon is having single bond and triple bond. So what we will call it as triple bond means sp hybridization. Same thing here also. This is hydrogen triple bond. So here also sp hybridization. Next, look at here. CH3 and single bond. All single bonds. We know that sp3 hybridization. Then if you come for here, CH double bond, single bond. So hydrogen single bond. This is double bond means what we will call it as sp2 hybridization. Same this side also double bond, single bond. So double bond we have to give priority sp2 hybridization. Here also we have to give hydrogens 3 are there, here single bond. So what we will give? All single bonds means sp3 hybridization. Next, look at here children, very interesting here. Here only trick is there. Many people they will do here wrong in examination. What is that means? See here, this carbon is having 2 hydrogens as well here double bond. So what we have to give? Single bonds, double bonds are there. So double bond we have to give priority. So it is sp2 hybridization. Next, look at here children. Look at here. See here, double bond. Okay. So how to consider? So can we consider it is a 2 double bonds? Okay. So double bond is there. Can I write sp2? Everybody will do here sp2 hybridization. Well children, we have to write it. It is, we have to consider double bond. So 2 double bonds, where it will be located? In triple bond. So that we have to consider it as a triple bond. So that we are, triple bond means what we will call as hybridization? sp. So it is correct, it is wrong. Okay now children, once again I will let me explain. So first carbon though we have very clear. Second carbon, if you take here, what is happening? Both the sides double bonds are there. Double bonds are there means what we have to think? Double bond is there means sp2 hybridization. We will conclude and we will write it as a sp2 hybridization. That is mistake, which is wrong. Then we have to look at here, both the side double bonds are there means we have to consider it is a 2 double bonds. 2 double bonds, where it will locate? In triple bond. So that we are considering as a triple bond. This carbon is having, then triple bond means we know sp hybridization. So I am writing here sp hybridization. So it is correct. So if you write sp2, it is wrong. Okay. Then this carbon is having hydrogen, single bond, double bond. So that sp2 hybridization. This is having hydrogens. All hydrogens we know that single bond. So that single bond means we know sp3 hybridization. Okay children, I hope you enjoyed this session.